Hi, welcome back everyone. Today we'll be doing a pretty quick section. This is first in chapter 7. This is functions of several variables. And this is basically to get our feet wet before we start working with calculus on multiple variables and partial derivatives. So 7.1 is just on the functions themselves. So for example, notation-wise, instead of f of x, we'll now have multiple input variables. So maybe x and y are both input variables. So if we let f of xy represent 2x squared minus 3xy plus 5, we could be asked to find things like f of 0, 1. So this is just saying all of the x inputs are 0, all of the y inputs are 1s. So this will give us a constant value. So as you can see, that's worth 5. The first two terms drop to zeros. They might have us do multiple operations. They might give us 2f of 1, 3 minus 5 of f of, well, let's do 2, negative 4. So we'll start with the 2 times f of 1, 3. So we're plugging 1s in for all the x's, 3's in for all the y's. So 2 times the quantity 2 by 1 squared minus 3 by 1 by 3 plus 5. And then we'll take care of the minus 5 times f of 2, negative 4. So my x is a 2. My y is now a negative 4. And we'll squeeze that plus 5 in there. All right, so we're still looking at 2 f of 1, 3 minus 5 f of 2, negative 4. And really after that, it's just arithmetic. So we have 2 by, let's see, 2 minus 9 is negative 7 plus 5 is negative 2. Minus 5 by 8 plus 24 plus 5. And then it's just plugging and checking from there. So negative 4 minus 5 times quantity 8 plus 24 plus 5. So negative 189. All right, trying to center that a little better. Okay. Now you are familiar with functions of multiple variables, if not necessarily in this notation from your geometry days. For example, perimeter of a rectangle with respect to the length and width would be twice the length plus twice the width. The surface area of a right circular cylinder, picture a soup can, that relates to both the radius and the height. So we have the top and bottom of the can, each are pi r squared. We have 2 of them, so 2 times pi r squared. And the label of the soup can would be height h, and the length of it, if you cut the label off, is the same as the circumference of your top and bottom circles. Circumference of a circle is pi times diameter, or pi times twice the radius. So a little cleanup on that one. Surface area with respect to radius and height of a right circular cylinder, 2 pi r squared plus 2 RH pi. So for example, if they want the surface area, given inputs of 50 and 25, so basically a radius of 50, a height of 25. So 2 times pi times r is 50, so 50 squared, plus 2 times radius again is 50, height of 25 times pi. So 50 squared is 2,500 times 2, 5,000. So 5,000 pi. And 2 by 25 is 50. 50 squared is 2,500. So 7,500 pi. And that would be in square units, whatever they gave us, inches, millimeters, yards, etc. Now occasionally they will have us, instead of plugging in multiple values, they may have us write a function in one variable given one constant. So if we define f of x to be cap g of x comma 2, and they tell us that g of x, cap g of xy, is x cubed minus 2x squared y plus xy squared minus y cubed. So then f of x, since they're giving us a constant for the y, now we can narrow down to a one variable. X is still a variable, so x cubed stays the same, minus 2x squared stays the same, but this y is now replaced with a 2. Same thing with our plus x, hang on to that, but y squared is now 2 squared. And then minus y cubed becomes minus, of course, 2 cubed. And we just do a little simplifying. So f of x, x cubed, minus 4x squared, plus 4x minus 8. So that's our one variable equation. Now that we have the idea of working with that, now we can sort of work backwards. So we're going to find all y. ST, remember, is an abbreviation for such that, excuse me, cap f of 4y is 0, and define cap f of xy as xy cubed plus 3xy squared. So we sort of have two pieces to the puzzle. One, we're finding what cap f of 4y looks like, and two, then we're setting it to 0 once we find what that looks like. So we'll start with cap f of 4y. So now all of my x's are 4's, y's are still variables. So 4y cubed plus 3 by 4 y squared. So cap f of 4y cubed plus 12y squared. Now that we've done part one of this, now we find out, okay, where is this thing equal to the 0? So 0 is 4y cubed plus 12y squared, and that one's just factorable by grouping. So y equals 0 or y equals negative 3. So those are all the y values that have the given property. This next one is a little bit more practice, only now we're throwing in one additional variable and doing something that is sort of the multivariable version of our difference quotient. So for this next example, so used to writing f of x y, apologies there, is x minus 2y squared. And we're going to find, again, sort of a relative of a difference quotient, f of x comma y plus k minus f of xy all over k. So k here is acting sort of how h did in the original difference quotients. So we'll find each piece one at a time. Make sure you are labeling them. So first I'll find the f of x comma y plus k. So x is still x. Y is getting replaced with the quantity y plus k. So x minus 2 by y squared plus 2ky plus y, k squared, sorry, k squared on the end there. So f of x comma y plus k, x minus 2y squared minus 4ky minus 2 times k squared. F of xy, we already have that, and k is just one variable out by itself. We've got all the pieces we need. So f of x comma y plus k minus f of xy all over k. Now we're down to just a substitution step. So x minus 2y squared minus 4ky minus 2k squared minus the quantity f of xy, that is x minus 2y squared, and a k at the bottom. So a little bit of simplifying. We have x minus x is 0. We have negative 2y squared minus a negative 2y squared is also 0. We can factor a k as well. So I'll factor a k up top. So I have k by 4y minus 2k all over k. And k over k is 1. So 4y minus 2k would be our difference quotient. All right. So finally, they have us working on just a couple of quick, relatively simple application problems, and then again, we'll, in the coming sections, apply them to calculus. So this next example, they've got us working through an example where we make two kinds of porch swings. And so our relevant information, we have a freestanding model and one that you can attach to a beam. So our freestanding model, variable cost is $150. Variable cost for the beam one, we don't need a whole setup to suspend the swing, just a couple of eye bolts to hook it to the ceiling. It's a little bit cheaper to make, so that one is $100 each. For the company, they have a fixed cost of $5,000 per month. So that's whether they make one of each swing, none of each swing, a million of each swing. Fixed costs are $5,000 each month. So from that, we can do a few things. We can, one, produce a cost function. So that would be cost with respect to the number of freestanding swings built and the number of ones that can be hung from a beam. $150 for every freestanding one, plus $100 for every one that can be supported on a beam, plus our fixed cost of $5,000. So then the next thing they have us try out is to find and interpret. So they picked out, as you can hear, my daughter is trying out her voice today. Find and interpret C of 75,150 for this problem. So for starters, we'll find the value, and then we'll actually say what that value means. 150, F is now replaced with a 75, plus 100 from the equation. B is replaced with 150, plus 5,000. So after that, plug it in, chug in, 150 by 75, plus 100 by 150, plus 5,000. So C of 75, comma 150, 31,250. Now, unfortunately, here in the notation, this comma is representing the fact that we're separating two variables out. This one is just from the fact that we have a 5-digit number. So here's the find part, the often left off interpreting part. What does that actually mean? So to make 75 freestanding swings, that's what the 75 means. She's really yelling today. We're making also 150 beam, we'll just call them beam swings. Company, I'll spend $31,250 in 1 month. So that is also including our monthly fixed expenses. Okay, so the last one, we're back to a little bit of geometry. So we're making an open top box. So basically we have 4 vertical sides, we have a floor, we don't have a ceiling. And one of my precious works of art here. So basically this top part is open, but all 4 sides have material, and the bottom has material as well. Open up here though. So for starters, we can make a formula to describe the amount of material needed. Based on the measurements. So we'll call the vertical one height, not super clever there. And then we have the width and the length. So the material needed depends on all 3 of those variables. So this is going to be a function with, instead of 2 independent variables like the last few examples, 3 independent. So we'll just do cap M for material, and it's dependent upon the length, the width, and the height. So we'll start with, I guess we'll start with the floor. material needed would just be the width times the length. It's an open top. I don't have a top on it, so just one of those width by lengths. Front and back though, width times the height, one for each, so 2 total. Same thing with the left and right sides. 2 of those, each one is length times height and dimension. So then with that in hand, they ask us again to find and interpret. M of 658. And each one of these we'll assume is in inches. So they gave us a length, a width, and a height. And we'll just follow our pattern. So width times length. Width was a 5. Length was a 6. Then our 2, width again is a 5. Height was 8. 2 from our formula. Length was a 6. Height again was an 8. So M of 658. So we're plugging and chugging there. Let's see. So we have 30, 80, and 48, 96. 17, 3, 20, 206. So there's the fine part. Interpret. What does this actually mean? So this is the amount of material needed to make a box with the given dimensions. So to make an open top box, with length 6 inches, width 5 inches, and a little bit taller, height 8 inches. That will take 206. No, notice this should be in square inches of material. So just 2 dimensions there, inches by inches. This is in square inches, inches by inches here, square inches here. Same thing here. Square inch plus square inch plus square inch is still square inches. All right. So we're finding and interpreting. All right, so some problems from 7.1 to try out. Again, 7.1, kind of a short section. Get used to the new notation in that. If you're in the older edition, 9 to 19 odd, 23 to 39 odd, 43, 45, 58, and 62. If you're in the new edition, current edition, whatever you want to call it, still 9 to 19 odd, 23 to 35 odd, 47, 49, 53, 55, 67, and 72. Should do it. Okay, if you have any questions, please feel free to get in touch with me. Otherwise, I will see you next time. Stay safe out there.